y equals 5. What's the slope? What does a graph look like? Horizontal line, so the slope is 0. So in other words, y prime, the derivative, no matter where we are, is going to stay 0. -3, because the slope is -3. It stays that constant slope throughout. And does it matter what this number is for what the derivative of the slope is? Why? If I change this number, what's going to happen? The position of the horizontal line is going to change, but the slope is going to stay even. It's going to stay 0. Does it matter what this number is? Yes, it does. This controls the slope. Does it matter what this number is? That does not control the slope. We figured this out on Tuesday. What's the rule? 2x. Nope. No, we didn't. Wanted to see if we had any guesses.
3x.
There is a 3.
3 squared x, which is just 9x. Close enough.
3x squared. And we'll, on Friday, at our Friday meeting, we'll do more of those limit proofs. And one of the things we'll do, actually, I don't know. I'll think about it. At least, if we don't prove it, I'll at least show what the proof looks like. I'll show you what derivative of x cubed, how we get the derivative of x cubed, how we get the derivative of x to the 4th, how we get the derivative of x to the 5th. And you'll be able to see that the pattern is that this exponent is going to hop down up front. It actually has to do with Pascal's triangle. This exponent hops down out in front, and we take one away from the exponent. Take one away from the exponent. And if you think about it, that rule works up here too. Right? This was an x to the 1st. So we bring a 1 down out in front, and so -3 times 1 is just -3. And then subtract 1 from the exponent, we get x to the 0, which is also 1. Hop down out in front, 2x to the 1st. So that's the power rule. On the homework, I gave a homework assignment yesterday, and I said on that homework assignment, you do need to show the entire process and work things out that way. So the homework is from the first section of this chapter, then you need to show out the work and show out the limit process as though you don't know any rules. And there will be a question on the test where you will need to show out the rule. But then after that, we're just going to be memorizing and knowing the rules. Remember, there's a couple different bits of notation. We have this like d by dx for that little nudge of x that we're taking. Or we can, another common bit of notation is a prime. So we had I had y prime on the last slide. Here's f prime of x. So the process here, that 4 is going to come down out in front. X to the 4 minus 1, so 4x cubed. And anything that you can rewrite as x to some exponent can be using this power rule. And so each of these we can write as x to some power. So think about what power we can take these to. And then use that to get the derivative. H prime. Oops. Should be in red. A cube root means x to the 1/3. And so the derivative, this 1/3, is going to go down out in front. X to the, 1/3, we're going to take the exponent and subtract 1. So negative 2/3. Which, if you want to rewrite it the same way with the cube roots, would be 1/3, and then we had an x, a cube root of x squared. That's x to the negative 2/3. Negative means it goes on the bottom, and then 2/3, so that's going to be a cube root of x squared. Over here, this is 1 over x cubed is the same as x to the that was this. This is x to the 1/3. If it's on the bottom, that must have meant because this is a negative 1/3. And so hop this down out in front. X to the, I subtract 1, so negative 3 minus 1, negative 4. Or you can, if you want to rewrite it as the fraction again, the negative means it's going to come down to the bottom. So negative 4 will mean it comes down to the bottom as an x to the 4th. And this actually connects with what we did yesterday. The proofs with the limits that we showed out yesterday. I actually showed some problems that turned out to be the power rule. So I'll show you those real quick. Which ones? Well, that one. We got 4. Big surprise. We didn't do this one. We didn't do this one. Oh, there's my x cubed. I'll show you that later. Here's square root of x, which is x to the 1/2. And so with our power rule, we know that 1/2 is going to come down out in front, and you're going to subtract 1 from the exponent. So it's going to be 1/2 x to the negative 1/2, which is 1 over 2 the square root of x on the bottom. So negative 1/2 means it's going to come down out in front. Same thing for, we did 2 over t. So if we do 2 over t, here's the limit way of doing it. Remember, we had to multiply that fraction. To get rid of that fraction and a fraction, we canceled out, and we got negative 2 over t squared. Because this was 2t to the negative first. So negative 1 came down out in the exponent. That's why it's negative. And then we subtract 1 from the exponent. So instead of negative 1, we got a negative 2. So just showing that that limit process gives us the same answer as what we had before. Okay. Going back to do more examples here. Find the slope of the graph at each of those points. So the slope at each of those points means that I'm going to, first off, take the derivative. And then after that, we are going to plug in those points. So we have x to the fourth over 4. I can also rewrite this, if it helps, as 1/4 x to the fourth. So f prime is 1/4 times, well, the derivative of x to the fourth is 4x to 4 minus 1 is 3. So 4x cubed. Which, these cancel, and we have just x cubed. And now we can plug in each of these points. F prime of negative 2 is negative 2 cubed, which is negative 8. F prime of 0 is, well, 0 cubed is 0. F prime of 3 cubed is 27. I've said before that 2/3 of the AP test is non-calculator. Everything we've been doing so far in this chapter, and I think everything on the test actually are considered to mean non-calculator questions. There are a couple of things on the last test that I would say would be non-calculator, or that I would say would be calculator questions. So, for example, where you had to do intermediate value theorem, coming up with a graph on that last question, I wouldn't have expected you to do that without a calculator. If we were taking it in class, I would give you a non-calculator part, and it would have been about 3 of the pages, and then a calculator part that would have been that 4th page, just to give an idea of about how much. The directions said to use the calculator to get the value, so. Did you have another question? You had your hand up earlier.
I was just gonna ask, I don't know if this was like the way you could do it, but could you do like the x to the fourth power on the top and make it 4, and then x to the third, and then cancel the 4, or is that not possible?
So the question is, can we say this is a 4x cubed over 4? Yep. That's the same thing. It just helps some people to see that this is just a 1/4 out in front. But if you see it this way, that's fine too. So something to keep in mind is at the end of the chapter, this is not too bad right now, and you guys have been pretty good at being able to come up with the answers to these, but just keep this type of question in mind for the end of the chapter. Because at the end, we will have a rule for, in general, when we are dividing two things, what the rule is going to be for what the derivative is. And it's going to be a lot more complicated than these problems. So keep in mind that there will be times where it's going to be a lot easier than it looks. So if you have a question like this, usually my rule is if it's just a number on top or just a number on the bottom, then you can just use the power rule. And you don't need to use, we'll call it the quotient rule, which is a much more complicated formula. So just keep in mind, some people look at a problem like this and suddenly try and do it the long way out without realizing that it's just a power rule in disguise. So keep that in mind as we go forward into probably 2 weeks from now. All right. Let's do a few more. You ready to try these, or do you want me to do them? Huh? Think you're all right? Okay. I'll give you a minute or two then, and then we'll put the answers on the board. The fun part is you can't see what I'm writing, but the people at home can. Got the first two? What's the exponent here? It's on the bottom, so it has to be negative. And then the cubed root tells me that 3 on the bottom of the fraction. Squared tells me 2 on the top.
Okay, so here's what I thought. I thought it was 2 to the third. See that?
Ah, I see what you're saying. No, 2 cubed root of x squared. Twos cancel here, so I can have a negative 1. And then I can put this back on the bottom if I want. I'll talk more about simplifying when we get more complicated things to simplify. Okay. Questions on that?